forgotten. Okay. So we're going to be exploring relationships between variables. In mathematics, we're often interested in using the value of one variable to predict the value of another. Okay, so first we have to establish, in order to make predictions, we have to establish whether or not there is any kind of association between the two variables. For example, do you think that there's a relationship between the weight of a sports car and its fuel efficiency? Mm-hmm. What is the relationship in general?
In general,
yeah.
Heavier,
yes, the heavier the car, the less efficient it would be. So pounds goes up and miles per gallon will go down. So what we want to do is to calculate a way to measure the association. How well does weight predict fuel efficiency? So we want to measure it. We want to define a statistic that tells us how well one measures the other, one predicts the other. Okay, so here's some data from Consumer Reports. And it is reporting EPA, city miles per gallon. So it has a whole bunch of different pieces of data here. But we are just going to look at its weight, which is right here, and its city miles per gallon right here. So we want to see if there's any relationship between the weight and the city miles per gallon. So do we think there's a relationship? Yes. Heavier will lead to less efficient. Okay, do you think it's going to be highly predictive? Okay, if you know the weight, will you be able to predict its fuel efficiency? No, how come? There's other variables that also contribute to fuel efficiency. So we might be able to predict it within some bounds, right, that account for all the other variables, but it's not going to be a perfect prediction, right? So not perfect, but predicts a reasonable fuel efficiency. So if you know weight, you can't exactly predict the fuel efficiency, but we could come up with some reasonable guess that would be not too far off. All right, so first we're going to focus on, so here is a scatter plot. I put all the data, and I put weight as the X variable and city miles per gallon as the Y variable. So this point right here is 3,235, 23. That means 3,235 pounds, 23 miles to the gallon. Okay, and that's the Mitsubishi, the data for the Mitsubishi. Okay, so do you think that this scatter plot reveals a relationship? Does this indicate that we're right, that there's a relationship between these two? Yes. Yeah, there's definitely a trend that as the weight goes up, the city miles per gallon goes down. Okay, so the direction of an association, we say, is either positive or negative. There's only two directions. Positively associated means that larger values of one variable tend to occur with larger values of the other. And negatively associated means that larger values of one variable tend to occur with smaller values of the other. So positively, as one goes up, the other goes up. Negatively, as one goes up, the other goes down. So does it appear that the weight of a car and fuel rating are positively or negatively associated? Negatively. As weight goes up, fuel efficiency, fuel rating goes down. So this is negatively associated. Okay, so now we know the direction. There's only two directions, positive and negative. The next thing we need to be able to discuss is the strength of an association. So the strength of an association reflects how accurately one could predict the value of one variable based on knowledge of the other. So we measure the degree to which two variables are associated with a number called the correlation coefficient, and it's we use the letter R to represent it. So calculating this value R by hand is really tedious. We're going to let our calculators do it for us. But I'll show you sort of the idea behind what it does. Is it draws in a line of best fit. Okay, it figures out a line of best fit. And then it measures the distance from every point to the line. So it finds the errors, right? It calculates all these little distances. It adds them up. And the size of the distances, if the size is very small, you get a certain R value. If the distances are really big, you get a different kind of R value. So this is how R is calculated. It's based on these distances. And the calculation works out so that if R is 0, that means the distances are really big. There's not really any correlation at all. And if the correlation is really close to +1, it means it's very strong, positive, in the positive direction. And if it's really close to -1, it's really strong, but they're associated negatively. As one goes up, the other goes down. So anything close to ±1 is a very strong association. Exactly 1 and -1 means perfectly predictive. All the data falls on a straight line. So what do you think the value of R would be here? You don't have to give an exact value. Just tell me where it might lie approximately. Good thought. Because it's not 0, because okay, yeah. So it's almost an even amount of distance on the top and the bottom. It's not 0, because 0 would mean that the data is totally random and doesn't lie in a line. It has to be negative because they're negatively associated. So a good guess might be -0.5. And that's a straight up guess, right? We don't know how R is calculated right now. But we do know that it's a negative association. So it has to be, R has to come out negative. And it's not 0, because 0 would mean total chaos, just a bunch of dots on the plane that don't fall around a line. But it's not perfect either. Perfect would be -1 if they all fell in a line perfectly. So this is just a guess, -0.5. Okay, so lucky for us, we don't actually have to figure out how to calculate this R value. We're going to have the calculator do it for us all the time. So correlation coefficients only measure linear relationships. So it's possible to have a relationship between two variables that is real. There's a definite relationship, but it's not linear. So let's say this is my scatter plot. You think there's a relationship between those two variables? Definitely. That is like a distinct pattern that is not random, right? Yet, if I were to try to create an R value for that, creating the line of best fit for this data would be something like, I don't know, that, right? and I would get an R approximately 0. So just keep in mind, it's possible to have a relationship that gives an R, that you get when you get an R value of 0. Doesn't mean there's no relationship. It just means that it's not linear. Okay. So it turns out that the value of R in our example is actually negative 0.82. So this is a really important bit of statistical analysis here, and you should remember this for your whole life. Every time you watch TV or read the news, remember this. Okay. Two variables can be very strongly associated by a correlation coefficient, so we can use one to predict the other. However, it does not mean a cause and effect relationship exists. It doesn't mean that a change in one causes the change in the other. Okay. Often the explanation is related to a third variable that's not being measured. So if you think about our weight of a sports car, miles per gallon, that probably does have a cause and effect relationship. Okay, the more it weighs, the more fuel it takes to move it, because it weighs a lot, so it's harder to move. So it does have a cause and effect relationship, but often there isn't one. For example, shoe size is strongly correlated with math ability for children in school. Children with bigger shoe sizes tend to be much better at math than children with little feet. Do you think that being good at math is caused by having larger feet? No. In fact, what actually happens here is that as children get older, their feet grow and they get better at math. So there's a third variable that's hidden there, age, that's causing both things. So this happens so much. I bet if you just watch for it for a couple of days, you'll find someone reporting in the news a correlation as though it's cause and effect. So you have to keep a critical eye when you hear about like medical studies, all kinds of stuff. In fact, if you find one, bring it in so we can all talk about it. So linear regression, or the least squares regression, is a formal mathematical model that we use to describe the relationship between variables. So we want to be able to predict fuel efficiency of a sports car by knowing its weight. So the simplest model for prediction would be a straight line relationship. And so our goal is to come up with an equation of the best fit line to model our data. It's called the line of best fit, or the regression line, or the least square line. So before we talk about how to get the calculator to tell us the equation of this line, we're just going to be able to interpret what the calculator gives us. So we're not going to come up with the equation of the best fit line by hand. The calculator is going to do it for us. Again, what the calculator does is it draws in all the distances from the points to the line to like every possible line, and it chooses the line that minimizes the distances, minimizes the sum of all the distances. So it chooses really the very best line to fit all the data. So my calculator, when I'm going to feed it the data, and it's going to spit out something that looks like this. Okay. So we're going to have a little shot in the home screen that says y equals ax plus b. So they're telling you this is a line. And they're using a instead of m. You know, we usually use m for slope, but they like alphabetical things. So they're going to use y equals ax plus b. Then they give you a value for a and a value for b. So the equation of this line is y equals negative 0.007x plus 41.68. Okay, rounded a little bit. And then it also gives you an r squared value and an r value. R would be about negative 0.82. So your calculator can give you everything you need to know about the best fit line. It gives you the equation, and it tells you how well it fits by giving you the R value. So to interpret the slope is negative 0.007 over 1, right? And slope is change in y over change in x. What does y represent in my graph? Just y in general. What are the units on the y coordinates? Miles per gallon. And my x units, what are those? Their weight. What is the unit for weight? Pounds. Miles per gallon per pound. So my slope is negative 0.007 miles per gallon per pound. So what does that tell me about the relationship between the weight of a sports car and its miles per gallon? For every one, yes, for every 1 pound we increase the weight, we lose 0.007 miles per gallon. And you said we lose it. How do you know that? Because it's negative. Yep. So you could read this as negative 0.007 miles per gallon per 1 pound. So shave off a little mile, a little bit, 7/1000ths of a mile per gallon every pound you increase the weight. So every pound increase in weight means a loss of 0.007 miles per gallon in efficiency. When you're writing sentences that interpret slope, if you use the word loss, you don't have to write the negative. It's like using a double negative in a sentence. So you could say every pound increase in weight means a change of negative 0.007, or you could say a loss of regular old 0.007. Don't use the double negative. Okay, so now we're going to see how to have our calculator do this for us. So it's a 5-step process. We have to enter the data, look at the scatter plot, find the equation for the line of best fit, graph the line of best fit, and determine the R value, the correlation coefficient. So there are step-by-step directions there, and I'm going to walk you through it. Okay, so we are going to use a fake little data set that's right here, X and Y. So if I were to write it out, my data set looks like this. X is 3, 5, 8, 10, and Y is 7, 8, 14, 18. So we're going to go through all the steps of how to get the scatter plot, the line, and the graphs, and the R value. So first, to enter the data, press the Stat button. Okay. Linear regression is a statistical analysis. So it's in the stat menu. Option 1 is edit. That's where we want to go. And then you're going to have a list 1, list 2, list 3 going across the top. If you have stuff in there, you can get rid of it by just deleting each entry individually. Or you can highlight the name of the list, press clear, not delete. Delete will get rid of the whole list, and you don't want that. Press clear, and it seems like nothing happens, but when you move the cursor back down into the list, all the data goes away. Clear. So now we type in the data, 3, 5, 8, and 10 in list 1. And in list 2, we put the Y data, 7, 8, 14, 18. Okay, so the next move is we want to graph this data. So let's just quit out of here, go to the home screen. To graph the data, there's 2 ways to do it. So the first way is the way that I wrote down in the little sheet, so we'll do that first. So right above y equals, it says stat plot. You want to go there. Okay, so we want to plot our statistical data. So you press second y equals, and we just want plot 1 to be on. Okay, so we go into plot 1, highlight on, press enter, and make sure that it says L1 and L2, because that's where we put our data in list 1 and list 2. So once everything there is good, quit out. And then I have to graph it, but I have to choose a good window, right? So I can see the 0.37 and 5.8 and 8.14 and 10.18. I need to be able to see all these points. So what would a good X range be? An interval of X values to use for my window. What's the smallest X value in my data set? 3. So maybe I'll go a little bit smaller than that. 0, sure. And my biggest X value, 10. So maybe I'll go a little bit bigger than that. I'll go 12. And then my smallest Y is 7. Maybe I'll start at 0 again. And my biggest Y is 18, so I'll go to 20. Nice round number. So you just go a little bit smaller than the smallest and a little bit bigger than the biggest. And then you just press graph. And your 4 points are plotted. Right. Anybody not have a picture that looks like this? Stat. Stat right there. And then choose edit. Yeah. Okay. Your calculator does have a shortcut when you're plotting data that will automatically choose a really good window. And that's in Zoom. Option 9 is Zoom Stat. And it automatically picks a window where you can see all your data points. So you can do it manually, or you can have the calculator do it. Okay, so we have entered the data. We've looked at the scatter plot. The next thing we want to do is find an equation of the best fit line. So quit out of here. So we're in the home screen. Oh, I wanted to show you another way to plot the data. If you just go to y equals, see that plot 1 is highlighted now? That's because we turned plot 1 on in the stat plot menu. You can also just turn it off and on in y equals. So if you go to y equals, you can just highlight it and it's off again. Put the cursor on it, enter, and now it's on again. So there's 2 ways. This one's a little quicker. All right, so we quit, and I want to do a linear regression. So use the stat button again. And this time, use the right arrow to cursor over to the Calculate menu right here. And we want to choose option 4, Lin Reg. In parentheses, it tells you that's ax plus b. So we want the equation of a line. So you hit enter. Then you're going to type in, you have to tell it where your data is and where you want it to put the equation. So our data is in list 1 and list 2. So if you look above each of the numbers in your keypad, right above 1 in yellow it says L1, and right above 2 in yellow it says L2. We want to use L1 and L2. They're in yellow, so you use the second button. Second, L1. Then you do press comma, which is right above the 7. Then you hit second, L2. So we're telling it that our data is in list 1 and list 2. And then I want it to take the regression equation and paste it into Y1. I want it to come up in Y1 so that I won't have to retype it. So I press comma again. And now I want to put a Y1 there. And the process for getting to Y1 is a few button presses, but it's not too bad. Okay, so to get Y1, use the vars button right next to clear. So you hit vars. Choose Y vars. Vars stands for variables. So sometimes knowing what they stand for helps you remember the keystrokes. So you press the variables button. Choose Y variables because we're looking for Y1. Option 1 is function. That's the one we want. And once you go in there, there's a list of all the Y's. So we want Y1. So your home screen should say linreg list 1, comma list 2, comma Y1. And this is telling the calculator do a linear regression on the data in list 1 and list 2, put the resulting equation in Y1. Once you have it typed like that, press enter. And we have a regression equation. Do you not have R values? Okay. So to get R values, if you only got A and B and no R squared or R, go to your catalog, which is second 0. Scroll down until you see diagnostic on. So this is a catalog of every command in the calculator. Diagnostic on. Okay. Press enter again. So it says diagnostic on, done. So once you've got diagnostic on, do the regression again. And rather than retyping the whole thing, you can hit second enter to pull up the last thing that you typed. Press enter again. This time, you should have R's. Yes, so you go to the catalog. So you press second 0. Scroll down until you get to diagnostic on. It's alphabetical. Then just press enter, enter. Right. So now we've got our regression equation. If you go to y equals, it's automatically typed in there. So you don't have to retype it. It carries out all the decimal points, all the decimal places, so you're not going to have any inaccuracy from rounding. So that's the advantage of having it pasted right into Y1. It's gonna make your answers much more accurate. Now, since it's pasted into Y1, if we did everything right, it should be there. Just press graph, and now you can see the data points and the best fit line. Okay, so the last thing you can do is once you have the regression line, the whole point of it is its predictive value. right? So if you know an X, you can predict Y using the line. So a handy little tool is your table. So we go to your table. So this is different from your list. This is just your table. You can type in any value for X that you want, and it will tell you what Y value the line predicts the data will have. So what's an X value that was not in my data set? Okay, so table is right above graph, so you press second graph. Can you just scroll and it doesn't let you type in? Okay, so go to table set, which is right above window, and you want the independent variable, that's X, your independent variable to set to ask. Okay, and then the dependent set to auto. So that way you can ask, you can give it an independent variable and it will automatically calculate Y. All right, so then go to your table, type in any value you want for X, like, I don't know, 12, and it will predict a Y for you. You don't have Y? Let me see. You don't have a regression and paste it in Y1.
I did.
Do you know what happened, I think? This is something that happens. If you highlight Y1 and press clear, it clears the equation from Y1. So to clear stuff, you just want to delete values from here, not highlight the list name and press clear like you do in the list. Okay, good. Okay, so project 2 is about linear regression. I have given you, I think, like 4 or 5 data sets here. I want you to just go through the process of linear regression. Find an equation. So I want you to write down the equation of the line and the correlation coefficient R. So find an equation, find the correlation coefficient R, and then say whether or not you think it's a good model. So you're going to do this in your groups for a little bit.